Okay, I think we're set. Okay. So if you're remote, let me know if you can hear. Otherwise, it's probably the time in mute. All right. Okay. So I hope that everybody had a good weekend. We're going to get this bad news email, but hopefully everybody's safe. Okay, so today is just a lecture. You should be able to access it through the website. Now, I think I found out what is going on. Or at least something strange happened today, where I cannot access anymore the website with Chrome. And I think that, that's a feature of the browser. So these browsers, they keep up to date. That's called evergreen. And so what they do is they sometimes update in the background. And since the, I guess, the last update, then this is what happened. We want the PDMS, right? You see, it puts an S in there. Yeah, that's strange. Atom is just I get an error. But basically, what it does is that I think it doesn't like the fact that this URL is not secure, and he forwards it to HTTPS, and then the server says, "I'm sorry, I don't know about this." But that seems to be also USC related, because Atom I have a different behavior than here. They say that I tried in Firefox, and Firefox lets me in. So if you have still trouble accessing the course on page, that's the way to go. I did open the lecture that should be in there, both the PDF and the online version. And then the lab and the assignment is also open. So this is going to be due in a week from now. So we're switching to Mondays now for delivering the assignment. Okay. So I'll get started with today's lecture. So this is mostly content that is useful if you need to put together a dashboard or an infographic. And so we're going to see a little bit what recipes people use for that. And then we'll go back to do a little bit more HTML, CSS, JavaScript, and how to use those for building plots in the browser. Just little things so that we get used to that. And that will lead to D3 later on. And I want also to talk a little bit, if we have time, about Vega and Vega-like. Yeah, if somebody can please share the link for the Zoom with the chat, because I think, Justin, yeah, no, that's fine. That's fine. It's more for next week. I was thinking that Vidit wanted to attend, but he's going to come for the lab. So an infographic, this is typically what you get. These used to be printed. Now they tend to be more responsive, meaning that and online, meaning that they adapt to the size of the display. And as you can see, it's basically the basic charts. You have pie charts and bar charts, and we'll talk about this one in a minute. That are put together in a way that it's nice enough so that people are willing to spend a little bit more time on it. Because there is quite a bit of text to read here, so these are usually created by journalists type of person, but they can also be useful for doing outreach if you want to explain how to stay safe with COVID. That's typically the type of thing that you would put. And obviously, you want to put some hard statistics in there if you're a data scientist. Can somebody tell me what this is? What's the name of this one? Yeah, so two times. Here I can zoom in. So we have 2 time snapshots here, and we have values with a line that connects them. Okay, so I guess maybe it doesn't look like the example that I gave earlier, but it's a slope graph. It's good for seeing changes between time periods. Also, the time is just 2. So don't confuse it with the other one that has this parallel axis that is more useful for when you have good model data or several features that you want to plot at the same time. And so those are the parallel axes where the axes are related to different things. Here they're both time axes, but they're related to the years, right? And so if you have a lot here, visually you're going very quickly to see which one are trending up, which one are trending down. Slope graph. Here it is. And if I remember to do this, I can maybe write it here. Slope graph. Okay, I won't finish writing it, but I guess I don't have the space. Okay, so maybe I can delete this. Okay, here we are. Okay, so that's the definition from Wikipedia of infographic. That is a short for informational graphic. Okay, that's mostly what you want to take from it. The other form that is often used is the dashboard, and that's something that as a data scientist you need to be able to know how to create. So there you have some tools like Tableau and other in Python that allow you to prototype some of these in a standard way, or you can create your own custom one depending on the cases. So I think I showed you last time the COVID website from up in Canada that had a custom dashboard, right? Those are good examples to have in mind. So how do you? The question here is really how do you build these? How do you set up the content? So most of the time, the infographic is for bringing information to people. So that's the goal of the visualization. Here, the goal of the visualization is the same, but the user is different. In this case, the user is more interested to understand how the data that are portrayed here are trending. And usually you do this for monitoring, right? So if you go to see the COVID website from Johns Hopkins, well, what you want to see is what happened since yesterday, or maybe what happened since last week. And you want to have those figures really quickly up to end. So usually it starts with some kind of hierarchical layout where you put on top the most generic trends, and then you can go down and drill down. So either by going down here in the page, or you have menus because here. So these are the Google Analytics that put up analytics on how many people are accessing the web page, from where they are accessing it, and so on. And so in the general informational part that is at the top, you see that these tend to appear here quite a lot. You'll see the same in other dashboards. So those are called big numbers, and they give you the overall trends. So if you're just interested in that, you see them there, and then depending on what is it that you're most interested in going and, exploring, then you can drill down. So all these are that I'm giving you are called design tips, basically, that people have developed over the years. Obviously, there is no real science behind it, other than the fact that that these have been created over time and validated with people. So, it turns out that these big numbers, people are getting used to it in the first place, but also they're known to be useful to most users of this type of dashboard, and that's why it's now a known recipe to basically create them this way. The journalists, they have another tool set really that they're thinking of when they're trying to do these building the infographics. And really the line between, I want to stress the point, between infographic and dashboard is kind of blurred, depending on what is it that you're doing in terms of data. Oftentimes you have enough data that really it's a dashboard. The dashboard is dashboard. I think the particularity is that it's more useful in terms of monitoring some trends, while the infographic is just for giving you some information that you do once. So it's not something that is over time. But really the forms and the way you put them together is quite similar. So you see here in the late 1900s, we have this person here, the reference to the Spanish, that put together this illustration here to try to understand infographics and how do you build it. And the idea is that you think in terms of dimensions. Here is it complex or is it understandable? So you can make it understandable, in which case you would simplify the content, but then obviously you're not putting all the information that you have available. You can make it complex, but then a lot of people will not be able to understand the information that you're putting in. So it's a question of trade-off, and the trade-off you make it based on the user and the data at hand. So here we go. Alberto Cairo, that is also a journalist, took the same idea and sort of refined it. So he calls this the visualization wheel, because that tells you, it's a visualization that tells you to build a visualization by understanding what is it good to do in particular cases. So the way you refined it is basically added a couple more axes, and you refine the definition of the axes, and then you see that he puts it in this with this dichotomy here, that the things that are more complicated and deeper in terms of data are at the top, while the things that are simpler to understand, but less shallow in terms of information value, are at the bottom. So I put here a table to try to explain what every one of these axes has to do. So you can go and read it, and if you read the chapter from Cairo that is related to that, it will explain you in detail why it chose those particular axes. So how do you, yeah, maybe I can say a word, but So figuration abstraction has to do with how much how many images you're using. So you saw the infographic with the pizzas, right? So that's good because people get attracted to that, and they understand that you're talking about pizzas as opposed to something else fairly quickly. But then the information that you're bringing forth is kind of is just what is portrayed in the figure, right? Opposed to that, you can use abstraction, and if you abstract things, then in this case it's a rather simple example. But oftentimes, what happens is that you make it more difficult for people to actually understand it. Let's see. Decoration functionality. This one is so here functionality is in the sense how useful is it to understand the data. As opposed to decoration, it's just about the graphics that have nothing to do with the data. Right? So you might make it appealing, putting nice things around, but then it might help in some contexts to see how, but it doesn't really help you to understand any information. Lightness density is just about how many things you put in a given amount of space. Unidimensionality, multidimensionality. These are about the type of forms that you're using. If you have one graphic for one thing, or you have multiple graphics, because usually each graphic is going to give you a different perspective and maybe show you different trends. And layers, the layers is a concept that comes in maps. So maps are basically a representation of the surface of the globe on a 2D plane. And you add layer to that for names of places, points of interest, road network, and so on, right? So the more layers obviously you put, the more complex it is to understand. And so that's this access here. Familiarity, originality. This has to do with what the user knows about the form. So everybody knows a pie chart, but not many know a stream graph. So when you use a stream graph, what do you do to compensate for that? And then the redundancy novelty has to do with how many times you explain something in the infographic. So do you repeat it multiple times in different ways, or is it something that you just show once? And so if people don't get it, they're basically out of luck. Okay, I didn't want to go through all this explanation, but I did it. All right. So we'll next week we're going to see a little bit more of these design trade-offs here in more details with and talk about what different people think, how different people think that you should act on those. So I'll go back to the browser with how you can actually use it for creating. And now that we know enough about HTML, CSS, and so on, for creating graphics. So obviously, when you do some Python, you end up with graphics in a notebook that happened by miracle. So this is happening in the browser. So all they're doing is using the browser. So we're going to see how that works. And if you understand it, then it means that you can do things such as custom dashboards directly without going to Python, because the things that Python allows you to do are sort of confined. So obviously the first thing that comes to mind when creating graphics is can I do it with just plain HTML? And is it worth that I spend my time doing this? Now it turns out that here, this example here, and you can, that's why I put them online. You can call in the browser, and here you can see that this is done with divs. And you can see the source code there, okay? So why is that useful? Well, it's useful because you do it with the bare bone thing that every browser is going to support, and that's quick to do. The drawback is that you're kind of limited in terms of what you can do with just vanilla HTML and JavaScript. So here I'm just using HTML. I'm not even putting any coding in there. So this just gets, it's kind of tiny, and it gets shipped with the page, which appear right away. So that's good if you need to do some simple bar chart. Okay. So another choice that you have obviously is to use SVG. Now the SVG, you've seen it in the homework. You can do it the hard way, where you write the thing in SVG, and that gets shipped with the page, which is good. If you don't, and that's good if you don't have too many data points. If you have your huge data set, then you putting all this into the page is probably not a good idea. You want to load the rest of the page, and then the graphic is going to come up maybe later on. So we're seeing here that the trade-offs have to do with the amount of data that you want to put in the page, and really the complexity of the graphic. So if this was a bar chart, then you would maybe get away with HTML. But if you need a line chart, then you don't have much choice than to implement it in SVG, because that's what is easier. If you want to stay lean, there is an option now with coding. So this one is done right with Google Charts. But there are these things that we're going to see that are called frameworks. And what it is just a machinery to allow you to do components in the page. So you could misuse it to do charts. And people have tried to do that and argue that why do we need spatial libraries when we can use a framework to manipulate the SVG, and then we're done. But nobody went to the extent really of producing something that is compelling and that is worth using. And I think part of the reason is that in the modern libraries that are doing this thing, such as Altair, in Python, that is using Vega and Vega Lite, you have more than just a graphing library. You have a way of specifying graphics that is convenient. And not just for people who know frameworks, but for everybody. And as soon as you start graphing, what happens is that you have really a wide range of forms that you can create. And so if you don't have really a library that helps you do that, you're stuck doing every one with kind of in a bit of a different way. And so that goes to the philosophy of the chart typologies, where you have one function for one type of chart, and you need to go learn the parameters for that particular chart. Okay, so how is this happening really in the browser? How do we go from either some HTML, CSS, or SVG, or even in the page, or generated with JavaScript? How do you go from there to what we see in the page, right? So the way it works is fairly simple. If you have not heard about document object model, that's basically what allows it. So what the browser does when it sees your HTML, CSS, JavaScript, is that it puts this into a data structure. And that's the first thing that it does. And this data structure is the DOM, that is the document object model, where document refers to the page. And what this data structure is basically a hierarchical structure that describes the document in a graph, where each node is one component, one block that appears in the page. Okay. So everything is blocks. A piece of text is a block, and it's linked to some type of container that contains it. That is also a block. Then you go up to the window that is the main realization of your page. That is also in the same form. So you see also that things like comments, if you put comments in HTML, CSS, wherever you are, there are nodes in this graph. And so those that they don't appear in the window, so they're actually not realized as a box, but that's what it is. If you want to understand a little bit this idea of box model, I did a simple example for it. So this is an HTML table. So in an HTML table, you declare with the table. This is something that is omitted, but you should have it, the body, that is the body of the table. If you omit it, then the browser is going to put it for you in. But here I put it because it creates an extra layer of hierarchy that is actually there in the DOM. And then you have rows, and inside the rows you have the columns with the TD. Now the uppercase, lowercase is not a problem for the browser in HTML, that's case independent. And then you see here that the text that is in here inside the TDs here is also a box. Okay, and this box is derived from the TD. So obviously you understand now that if you have a graphic is an SVG, right? And inside the SVG, you're going to do circles and whatever node you've been plotting down to the hierarchy. Now the SVG is a little bit particular, and we're going to see in that it doesn't really have a hierarchy, but unlike HTML pages. So this box model lives in the DOM. And when the browser needs to put it on screen, it needs to know how you want things to look. And one of the first things that it needs to know is if you want the box to be in line or as a block. So if it's in line, then it's going to appear, as you can see here. So this piece of text here is a span that is by default an inline element. So it appears at the same level as the text. But if you have a div or a paragraph, for that matter, its default is type of block. And then what happens is it's going to fill the whole space, which for us is a problem because we usually want, we have bars, we don't want them to go all the way through the page. So this you can control with CSS. That is cascading style shield that basically tells the browser how things should appear. And there are obviously a bunch of defaults, such as those that apply to span to divs, that you learn them, but yes, so some are not integrated. So the defaults you can always override them in line with the style attribute. And here you see that I'm changing this div to be an inline type of block, so that it just behaves in the same way as the span. Okay. So I do it here by code. These things, you don't invent them. You can just go, where is it? I'm getting there. Okay. I don't know if I put this as code. Did I? Yes. So this is a div here. Here we go, right? So here you see that you have the style. You can go and edit these things. So you can put the display in line, and it does what you expected. Okay. You see that the block here gets changed into line, so they changed it in the code. Okay. Now, if you don't remember what are the options, then you can go here on the side, and you get a drop-down menu there that shows you what are the options. Okay. So you don't need to learn them all because they're complicated, and in particular the flex, but there are a few that we're going to be using constantly. Now, I'm telling you all of this because I mean, it's not too useful, right, to create this bar chart with HTML, but it's useful to know how to use D3, because then you can do whatever you like in terms of custom graphics. And if you don't know this, then you cannot use D3. Because all D3 does is that it allows you to get your data and to build a DOM for it. And then the browser takes care of rendering it. Okay? So keep that in mind because that's useful. Okay. So I think I told you already about this, but here are some examples of how to do graphing with this in these three ways with code. Okay, so with the code, you want to get a little bit organized, and we're going to see this in the lab because you have multiple choices. So when you want to size a bar or set the style, then you can either use classes, or you can use the style, or you can use the attributes. So you want to know how to do it in the three ways, but somehow have a preferred one. So usually things such as classes, because they apply to a number of to a class of elements in the page. You use them if you want to style all your bars or your bar charts. You want them to have the same visuals. Then you're going to create a class for that to set a given color or whatever. The style applies just to one when you use it in line. And here, for instance, we're setting the width of the bar because we want just that particular one to be of 600 pixels and not all the others. Okay. Now, some of these you can also use as attributes. With D3, usually we use the style. That's why I'm showing it here with the style. So this is with doing a bar chart, basically one bar with a div, using a class to set up how it looks and sizing it. Okay. The default height of the bar. Can somebody tell me what is going to be? If I do just a div here in this way. So you saw in my previous example, if I do a div and then it's going to take the whole space, so I need to size it. But the height is kind of standard, right? And so that depends on probably the font size that you want to use, or you can use the height parameter in the style. Okay. So here my guess is that the height I'm using it in the class. That's why you don't see it here. With SVG, so this is how you do a circle. So if you want to do a scatter plot, you need to do many of these. So you create your SVG element. Here I'm not giving it a size. So if I'm logging with the coordinates, the browser is going to do the right thing and give us the space to see them. But if the coordinates are way off the page, then probably I need to do something about that. And I want all my fonts to have the dot class so that they all look the same. And you remember that for circles and CX, CY, and parts for the basis. So all these attributes here that we've seen, they're global attributes, such as ID, class, and style. So it means that you can use them both in SVG and HTML, because all the elements that comprise the HTML standard have those attributes. But then you have some elements that have specific attributes, meaning that they only apply to them. So here, for instance, the circle, the CX, CY, and R, it's only for the circle. Okay. So whenever you have a specific one, usually you tend to put it this way. I think I have some slide about the styling with the attribute, but just for a word of caution. Okay, so when you want to color an HTML element, which includes an SVG element, just a circle, you do end up with all these options here to add, sorry, the spacing. Yeah, so this is box sizing. I'll go back to the coloring after. So you end up with choices here to set some padding around the element, a border, and a margin. And so those you can usually apply different units to them. But most of the time we stick to pixels because that's what we're most comfortable with and what is most useful for doing graphics. So how do you see these? Let's say here that I want to go and see. Yeah. Okay, here you see the green border there. So that if I click on it, the green border is the padding. Here, the little green border is the padding that looks like a couple of pixels. If you want to see how it is, I think Compute tells you. So you see here it's 5 pixels. The padding, the box is 950 times 42.22. And there is no margin and border, right? So here, if I want to add the border, okay, this one is complicated. Oh, here the pre has 20 margin. So if you want to add the border, we can do it here, or you can go in the style border. I don't remember if it's solid. I think it's red 2 pixels, something like this will work maybe. No. So what happens if you set up things wrong? Obviously, the browser ignores them. So I don't remember the syntax, but it's here. So if you don't remember by heart, because these are these blue, yeah, you need to look it up online. Sorry. So there are different ways. Oh, here it's the other way around. It's 1 pixel solid red, because you can have it stapled, etc. So if I put 2 pixels solid, then the default we get is black, right? And this works also here. Solid, okay, 4 pixels. Okay. And if you want it red, then you have it red. Okay. Now, this is useful as opposed to spend 3 hours writing the code and trying to guess what is right that you want. You just go and tinker a little bit like this in the browser, and then you can copy this into your code. Okay. The color and the tags. Yeah. So for HTML, it's rather simple. Color is the color of the shape that applies to the whole element. No, sorry. It is the color of the text. The background color is the color that is applied to the background of the element. So let's change for that thing here. Let's change the background. Where is it? So if you don't have it there, I think we can just add it here. Background color. Alice blue is a nice color. Okay, I don't know. Orange. Okay. Okay, so that's more complicated because my slides here they have a weird CSS. So most probably I need to put important after. No. Okay. Okay. So maybe the pre doesn't like that, and maybe the pre doesn't like it. Yeah, maybe the pre doesn't like it because I think the pre is this is for formatting, and the code block is so that the things are not interpreted. So if I want to write some HTML to show it as code, I'm going to use the code element, and for formatting I would use the pre. So new lines are actually used, but this is it looks like you cannot set up styles on this thing, or maybe not the background. Okay. Okay, so here you see the example and the code that is at the bottom, so you can go and play with it. Now you know how to do it. If you want to size, so these are some examples of using style with size. And you see here that we're using also height in pixels and width to set up the size of the bars. Okay. Okay. So now, oftentimes, what happens is that you want to use the same CSS attribute on multiple bars. So you can use obviously the class, but another way to do this is to use CSS inheritance. So the idea is that you wrap it with an element that you style, and then that style is going to be applied to the children. So think about the tree again. So if the parent has some CSS that is set up that applies to the children, and the children don't override it, and in that case, you will have the same rules applied to all the children. And so the way you do it here is very simple, right? You put the style on the outer element, and it's going to trickle down to the others. Okay, SVG compared to that is a little bit different, right? So in the first place, you saw that we're doing things in pixels. We're starting to the upper left corner. And here we're going to learn that there is no hierarchy in SVG, so you cannot put elements one inside the other. So the way things are rendered is the first one that you plot is going to be in the back. The last one is going to be drawn last. And if it's with the overlapping, then it's going to be over the first one. Okay, so here is what you see here. Typically, the green was drawn first, the orange second, and the blue last. Okay, so the drawing order is related to the coding order. And that's called the painter's algorithm. The rest, I think that we've seen this already. Okay, so if you compare both HTML and SVG in terms of how do you do placement and sizing, the primitives that you have to work with, the text, the drawing order and hierarchy, you will see that most of the time using SVG is simpler if you want to do graphics than obviously using HTML. And the reason is that SVG is done for doing graphics, right? So there is not much to be added there. This is not to say that you cannot do circles in plain HTML, because you can actually kind of do a decal object that is on top. And so you can actually have circles in HTML, but it's more complicated, while it's kind of native in SVG. Now the SVG, I don't know if I mentioned that, but if you see it around, the element that is used to draw in the browser is called the canvas. Okay. So which things that you have at your disposition to plot? So we've seen all of these already, including the line. We didn't see the polyline, the polygon. The ellipse, you've seen it in Inkscape. So Inkscape, if you're not careful on how you create the shape, you don't you do a circle and it starts with an ellipse, right? And if you look in the code, you will actually see that it's an ellipse element that is drawn, which is kind of makes things complicated to get the parameters of that if you're using it in poly. You've seen that, you know. Polylines and polygons, the difference is that one is closed, the other one is open. I have some examples on that right here. And so, yeah, so these I think we've seen them already. So the polyline, polygon, they go to waypoints that are tuples here, so it's separated by spaces. And it's basically connected to these points for the polyline without closing. And for the polygon, it actually fills it, it closes it and fills it. So you see that here the field as a default that is not set. And I've written it there so that you can see it, but that's basically what happens. Now, those seem simple enough. The problem is that as soon as you mess up anything in the syntax, then you end up with weird things. So let's see here, the rectangle that is in 1010 has a width that is misspelled. So it gets the default. The default for size is 0. So you won't see it because it's not drawn. Okay. So those you need really to keep in mind, because a lot of the time it is, oh, I don't understand, I don't see any of my points. Well, you forgot to put the radius or you misspelled it. Yeah, and see here I put some of the defaults here. What happened? So here we didn't put CX and CY, so those are 0. And so like this one, this green circle that is starting here, and it goes outside of the SVG, and so we don't see it. The line is not seen because the stroke is not set by default, so you need to put the stroke, otherwise you won't see your line. The polyline is the same thing, and here I misspelled the point. Yeah, the text element. This is how you do a text element in SVG. So you cannot use HTML inside the SVG, and that's a little bit of a pain because you cannot do easily new lines. There is another element that allows you to do that, but that's kind of complicated. I think I know more if you did it with just 2 pieces of text. If you want to add 2 pieces of text in the bubble, then it's good enough. And the text requires an X and a Y. Here we didn't set the Y, so it's the default is not set, and so it's not visible either. Right, so all those were attributes. Now you can try to slap those into style. Oftentimes it used to be not working at all. For instance, for the rectangle, our X and our Y, you couldn't put in style. Now you can. So it's kind of hit and miss. Most work now, before most didn't work. So you want just to be careful with that. And this is the rendering of these, right? So the last 3 here are not seen for various reasons that are explained here. Okay, positioning text. So again, this is SVG text, and probably you've seen this in the homework. It was a little bit tricky to play around with the text. And that is because in SVG, the text starts at the lower left bottom always, unless you change that. So what is convenient most of the time, if you have bubbles, what you want, or you know, if you have tick marks, what you want to do is to align the text with that axis. So what is convenient to do is move this point in the middle, in X and in Y too, right? And then you can have the text center at the point. So the red dot there is technically is called the anchor for the text. And so what you're doing is changing the anchor for the text. So if you have maybe I can give you yeah, here this is working. Yeah, great. So if this is my text, the default of the anchor is here. Okay. But if I want to place it in the middle, that would be here, because say that this is, oops, okay, this doesn't work if I zoom in. Here, because say I want to have a bubble around it, right? To place the text, what I need to do is move the anchor from the left start to the middle center of where I want to place the text, and the text is going to be centered around that point. So all you need to do is put style text anchor set to middle, and alignment baseline, that is for the vertical, set also to middle. And I think I had this in one of the function, text centered, in the lab. I think that was using that. Sorry? Okay, I'm sorry, I can't understand you. I'm sorry. If you want to repeat, otherwise, and maybe we can discuss it after. So this is the example of what I was just telling you, right? On how you use it, style, text type middle, alignment, line middle. You can use their attributes. You can set them as attributes, or you can set them with the style. Okay. The only thing difference in attribute and style you see in terms of the syntax is that it's always attribute equals something. When you put it in style, you need to put the semicolon. Okay. Those are a little sometimes tricky to spot when you have them wrong, because they nothing happens and you don't know. So these are, you can play around, but these are some quiz questions, so you make sure that you understand what this means. So I'll pass them, and then we'll probably we'll do a 10-minute break. so that we have a good hour to finish up with D3 and the Vega Vega Lite. We're more or less at the middle. Is that good? So yeah, we can do. Yeah, okay. Oh, good. Okay. Because I know I know that the other day. Yeah, I think that I answered in yeah, somebody asked. I said yes. Yeah. Oh, okay. Okay. Yeah.
So I have questions for this one. Do you mind I ask a question?
Sure.
So I can see that the radius is 0, so there's no circle.
There is no circle.
Yeah, but
So
why?
this is the rendering of it.
Yeah, but why there's no text?
Where there is no text. So you remember for the text you need to place it. You need to have an X and a Y. And the default is 0, 0.
So it's actually right here.
Yeah, it's actually right here. Yeah.
Oh,
Okay,
okay.
this lower button. So even though it's 0, 0, it just appears right on top because it's sorry the left bottom. Right?
Oh, okay. So and that is
Yeah, and then
the default.
the default is yeah,
Okay.
exactly.
On the PDMS website, is there something about project proposal? Are you going to go over what that is? What we're going to do for that?
I'll do it at some point, but which week is it?
They said I believe it was either this week or it was last week that it's under assignments of project proposal. It was due like November 21st or something.
Okay, so check if it's this week or next week, and then I'll cover it. Well, hopefully, hopefully it's next week. Oh, 9:29. For lab 3. Okay. Yeah. Yeah, it's this week. This week. Yeah.
It was actually it was first mentioned last week too.
Oh, it was mentioned last week. Google Slides. Yes. Yeah. Okay. So I had this kind of formal in the past. I'm trying to do it informal so we don't lose time with presentation and stuff. And so the idea is that we do it as Google Slides. Okay. So what I can do is I do have some material to give you an idea of the scope of the projects. Okay. So maybe I should plan to present that still. Okay. And then we do a kind of QA session. Okay, sure. Let's go. Okay. Yeah, thanks for pointing it out. Oh, wow. Yeah, okay. Okay, so maybe I'll restart. If you want, you can even finish early. Okay, so okay, let me see, do we have, yeah, we have sound. Okay, good. Intro to D3 and then vegan light. Okay, so these are just mostly for the quiz. Because I think we've discussed them. So the short story about D3 is that it's just a JavaScript library that allows you to put your data into the DOM. That's the short story about it. Okay, so that means that if you want to use certain marks for your data, such as points or bars, you need to tell D3 how to create them. If you want to use certain colors, then you need to tell D3 how to create them. And guess it, you do this with HTML, SVG, and CSS. and that's it. So once you get to the point that you can tell the browser how to create this hierarchy of SVG, because that's what you do most of the time with D3, then it's going to do the rendering, and you don't have to worry about it, right? So this is not to say that you cannot use D3 outside of the browser, but in that case, there is no DOM is there, and D3 doesn't know what to do without it. But obviously, people have encountered that problem before, so they created what is called a virtual DOM. So some of the frameworks they use that too. So React, for instance. So they have a copy that they keep up to date, and that allows them to do faster updates. If you're rendering without a browser, it's called headless. And in that case, what you do is that you use one of the libraries that are creating this virtual DOM, and you tell D3, here is your DOM, just work with it. And you can do printouts, etc. And so that's something that people does if you have to generate multiple graphics programmatically, and you don't need to look at them. So that's one way to work on it. So there are two ways really in which you interact. This is actually not true. It's not just with HTML, but it is true both with HTML and SVG elements. Remember that the SVG is part of the HTML standard. But so here I should qualify that. So you have two basic mechanisms. The first one is to select. So this is style. I don't know if you're familiar with jQuery, but that's the type of interaction that you do with it, where you basically select in the DOM tree, and then you can append nodes or remove them and change the property of the nodes. And so I call this the select and append mechanism. But usually you just create them and then they're there in the graphic. But if you want to do interaction, etc., it's a little bit more complicated, but you're referring about the basics. The second mechanism is called data join. And we're going to see quickly how it works today. And that's really what you want to use 99.9.9% of the time. What this does is join that's what it says. It joins the data with the DOM, and that's why the name D3 that is short for it's data-driven documents, right? So your data drives the DOM, and then the browser takes care of showing it. DOM in the sense of query. What is good about the second option is that it's scalable. Because the problem with the first one is that you need to do loops. If you change your data or you add data, so for each element you need to go and build these loops, the data join does it for you. So once you write the code, it's going to be exactly the same thing if you have 3 elements or 3 million elements. Not exactly, because with 3 elements it's going to be much faster, but aside from the speed, that's a little bit the idea. So same code basically, so you can make it scalable. So if you think about the option number 1, that is the select append, is what you would do using imperative programming, where you say what needs to happen. I want to create a dot here and another dot and another dot. And so that's kind of specifying how you want to do things. So it's fairly low level. And it's less accessible in the sense that if you give the code to somebody and they tries to understand it, it's going to be complicated for that person to understand it if they don't know the programming good enough. And this model is what is implemented into the parts. Map of different the same with here if you want at a different level, but those are typical examples. What D3 does with the data join is this declarative programming. And there you specify what you want to do. So it's higher level. You don't say that you want to get these points here in the page. You just say that you want this data to be mapped in this way to the doc. And so you're at a higher level of abstraction, and that makes the code more accessible. Now, it doesn't mean that it's easier to debug, because you're kind of calling high-level functions that do things, but the amount of code that you write is simpler, and usually less. Usually, not more. That's the case of D3. ggplot2, you can also put it maybe that realm, but ggplot, we've seen that it's a grammar of graphics. And so this is much less verbose than the D3. Because the grammar here are the final set of possibilities that you can use, and it's very high level, where the D3 is meant for you to do anything you like. And so it can get pretty complex. Okay, so let's see this weird animal in detail. So this is the minified version of it. That's what you load 90% of the time. Because usually it's better for you to just go look at the documentation than to go look inside the library code to understand how things work. The documentation gives you example on how you use things. And if you understand the declarative way of doing things from the documentation, that is enough to get around any problem. Okay. Now, if you do some extensions or something that is of that nature, then it's useful to go and look in the source code of the library. In that case, you don't load the .min.js, but you just load the library unminified, so you can make sense of it. So this is not something that is. The other reason I want to show you this is because you see some text, for example, closure here, where you see that here the way the library is loaded is by executing a function that loads all the objects that comprise the library. And this function is in this type of signature, and it's called that immediately invoked function expression. You know what the function expression is? That is there. The immediately invoked are the parentheses around it that make this a function that I can just call now. So as soon as this script minified.min.js, you ask for it in your HTML page, then the library is instantiated automatically. That's what this is doing. So this is another example of design pattern that is often used in JavaScript. Yeah, so these are generalities. You'll see in the documentation that the single most largest contributor is Mike Bostock, who created it. I think it's part of his PhD work. The website is there. The documentation is on the GitHub. And it's a little bit tricky to get around because it's not one library, but it is a set of libraries. The main library has most of the things that you use often, but then there are sub-libraries that are either helper libraries or things that are seldomly used that you need to make sure that you can use that you use when you need them. So if sometimes you don't find something in the main wiki here or as the main library, you need to be looking around, and I'll try to point you. Again, similar to as we saw with the Google Charts and the Google Sheet and all the visualization. To build, you don't want to just start coding line by line. You always want to start from a working example, even a very simple one. And so usually what you do is that you go look for an example in the gallery that is as close as possible to what you want to do. And then you can go look in the documentation to see if there are things that you don't understand in the code that you may need to change. So that then you're ready actually to use them. Yeah, always a bad idea with declarative programming to just trying to go and change things without understanding the logic, because things need to happen in a certain logic, and if you change the order, then it just doesn't work. I think I told you about the rest. That this is important, that it concentrates on the data as opposed to the representation. What that means is, unlike the Google Charts, we're not going to say we're thinking about doing a line chart. We don't care. We concentrate on the fact that we have some data and how do we put this in the DOM. The representation it comes really last. While with the Google Charts, you've seen it's the first thing that you decide. And obviously, because it's completely open, then it's very expressive, meaning that you can do anything that you can imagine with it. And you'll see in the gallery some visualization that are quite interesting. So a few things, again, mostly for the quiz. What D3 does, so it loads data in the browser, and importantly, it doesn't type the data. Okay, so as soon as you put something into the browser in a web page, there is no way that you can hide it, because you can go, you've seen with the inspector, and you can look at every bit of it. And if it's data points, even if you minify your code, the numbers are going to be the numbers that you put in. Okay, so the data are not hidden in any way. So it binds the data to the document elements, to the DOM, so this we've seen. It transforms elements by interpreting each element found data and settings with the properties. So what this means is that is able to take the elements in the DOM and transforms them. So if you want to move a point around, it's done based on the values that are attached to that. So what you're doing really is taking your data and attaching data to somehow a property of a node in the DOM, and you can set up transformation so that D3 automatically is going to handle the transformation for you based on the data. The data here is similar because it's a single part of your data set that you're attaching to a node. Then it transitions elements between states in response to user input. So this is to say that I can click on one chart and then something may happen in another chart that I did with D3. So or in the same chart. And the way these things happen could be that the other things are moving around, or that they appear or they disappear. So the transition is intended in that sense. So this is to go back to the basic operation that regard the select and append mechanism. So I want to basically select some nodes in the DOM, and then I want to append something that is going to help me draw a point if I want to do a scatter plot. And so the basic operation to do that are here selecting elements, adding new elements to selected elements, deleting selected elements, and modifying selected elements to position and style. So this is just a preamble on how to do it, because D3 uses the declarative syntax, and in practice the way it's implemented is with function chain. So you've seen that in JavaScript objects you can if you put a dot after, you can get the property or the values that are attached to the keys for that particular property. That's also, the dot is also a way to call a function, right? So if the function is part of the object, because functions are like any other like an object, then you can call a function on an object, and functions can be part can be properties of the object. So if I have functions here that here are three methods, and I want that one calls the other that calls the other, so that I can pass on basically the object itself, and I want to each one implements, say, the first one is implementing adding an SVG. The second one is implementing adding points based on the data on top of the SVG, and the third one is implementing coloring the points. Okay. So one way I can implement this in JavaScript is to have the three methods call each other and pass the object around that handles the state of the visualization. So this I can write either like this or like this, where I have intermediate variables, as long as each one of the methods returns the object itself. Right? So method one is going to return myself, and I put it into a variable, and then I call it dot method two, and I return myself, and I call dot method three, and I return myself. It's exactly the same. A nicer way to do this is like this with chaining. So here we just do it in one go, and this variable handling here are handled automatically by the returning a reference to the current object in one of the methods. Okay, so here this is really method one that calls method two that calls method three in one go. Okay. So in practice, how is this implemented? Very simple. As I say, every JavaScript object has this reference that corresponds to the current instance. And so all you have to do is your method, the thing that they do is that they return this, and then you can change it. Yeah? It is not more complicated than that. And so that's the basic mechanism that you'll see throughout with D3, starting with the selection. So here you have D3.select. Here you need to pass a selector string. So this is the select function that takes an argument that is a selector. The selector is a CSS style selector, elements such as those that we've seen in the CSS rules, right? You can either select the first element or that matches the selector, or all the elements in the tree that match it with the selector. Okay, and the return of this is a selection. that is not an array. It can be an array or something more complicated. We don't know what it is. Mike knows, but for us, it's just a selection. Okay. And what you can do with the selection, you can reuse it there to select other things. So if you're at a certain node in the tree, if you want to select your children, then you can call it again the select and select all, because this is returning a reference to itself with the chaining. Okay. So here you see this in work. So we're selecting the body of the document. Then we select a paragraph. So we can do it with the variable. We can do it with chaining. That is simple. Here we want to select all the paragraphs and so we don't specify where, because we're starting with the week3-select all signature here. So we don't say what is the file. So we're going to go just down the window and select everything that has a P. That is a paragraph, sorry. Here we select a chart that has an ID chart. Okay. And here we select everything that has a class plate. Okay. So now that we know to select elements, how do we add elements to the selection? So it's very simple. You just use the chaining syntax. You say this select the body, and then append the paragraph to it. Now, the only thing that you want to be paying attention to in this slide is what is underlined here, is whatever you append as the last child of the selected element. Yeah. And remember that everything in the DOM is a node. So whenever if I select a text, a piece of text, I'm going to be appending next to the text string. Under is node. I'm not appending after the text. So we're going to see this given. You see here the example. So here I have. This is what I have in the page, a paragraph with text, and that is inside the body. This is going to be visible in the page because the text is inside the body. If I put it outside, I won't see it. So I start selecting all the paragraphs, and I'm starting nowhere. So I'm selecting everything that I see, and I get this text 0 here selected, right? And then if what gets returned from the selection, from the select all paragraph is the selection. So I can use it to append a paragraph to it. And this is going to append as the last child of the text. Okay. And I'm adding another piece of text, so you see that the text appears here. So the people get confused with that. I think I put a figure. Did I? Oh, here. Yeah, I did this because it's confusing. And so this is what happens in the tree. The text is a child of the paragraph. And your next paragraph is going to get appended as the last child of the paragraph. The first child is text 0. And so the child of text 0 is going to become this new paragraph of text 1. And that's why it appears inside. Okay. Now this is true only with HTML. With SVG, it's simpler because you don't have the hierarchy. Okay, good. So the delete is as simple as doing a select and remove, right? So you just call remove on the selection. The selection keeps track of what is selected, and you just call remove and you're done. Okay. So if you want to modify, so here you have a couple of ways with HTML. that also act on the selection, as you can see. The first one is to change the text. You call the text method, and you give some other text. If you want to style it, you can call .style, and you can set your style. Yeah. So you see that the signature of style is not style equal and a long string, but it's a property value. So if you have multiple styles that you want to set, then you need to chain them. Yeah, it's not too complicated, but so here is an example with divs. So here, instead of using the style, we're setting the attributes. So where the attributes is attr. Okay, so you say same thing but attributes. And so here we're selecting a chart. We're appending a div, setting up the width, setting up the background color, setting up the text. And so this is enough to do a bar chart with HTML with div, right? And this mechanism here of putting a div in the page, you've seen it with the Google charts. So that's exactly the same thing. Only this chart is going to be processed with this JavaScript script. So it makes sense to give it an ID as opposed to a class. And then what you do is that you select it and you work with it. Okay, so here are some examples, and really the only complication is to understand that you're dealing always with the last child. Okay, so play around with it, and then you hopefully you'll get this. So, and I put a few, more than a few, more than a few. Okay. Okay, so here is the data join. So this is the second thing and probably the last that we're going to cover today. What time is it? Yeah, we have time. Okay, and this is more or less, once you know this, you know to use D3, and you should, with HTML, then we're going to see how to use it with SVG. And then we're going to so at that point, you'll be able to do any simple graphs such as bars and scatter plots and bubbles, or yeah, not word bubbles. Bubble charts. The word bubble, the problem is that you've seen that if you want to make them nice, you want to have some type of arrangement for the bubbles that is pleasant. So that's not easy to do automatically, right? So D3 has a mechanism that it has an algorithm that allows you to do that. And there are all class of graphics that fall into the same category where you need some algorithm to place things in the graphic, and those are called layouts. So that's the following thing that we're going to see, and more or less that is going to be it for D3. At that point, you should be able to do any graphic that you like. So this is the data join in a nutshell. Again, you start with your data, because we concentrate on the data and not on the rest. And the data is always an array. Therefore, it can be an array of anything, but it's an array. Okay. So here is the simplest case where it's an array of 3 numbers. And then you do this selection and append mechanism. You start with that, but instead of doing the append as a regular append, what you want to do is append this data set somehow to the DOM, and that's the data join mechanism that is here. So the append is a little bit more complicated, and that's why it's called a data join. And we're going to see step by step how it works. And you see it's all based on the chaining syntax. Okay, so this is the example, and on the right side, I'm putting the DOM tree, so you see at the same time what is happening. So at this point, we select the body. So here I show it in green. So this node in the DOM tree is selected. We select all the paragraphs that are in the body. Because we don't have any, at this point, we have a selection that is returned that is empty. It's an empty selection. And so the selection object is keeping track of that. It's saying, okay, I didn't get to select anything. The following statement here, declarative, all this is declarative, is saying, by the way, this is my data. Now I told you I've selected all the paragraphs, and I'm telling you this is my data. So my intention is really to bind this data to these paragraphs. Okay? Now, how do I do this? So then I specify it after, and I say, well, if there are no paragraphs, then you need to create some. This enter means if there are no paragraphs in the selection, and there are more data than paragraphs, I want to enter new paragraphs in the selection. And on those that enter, I'm going to do something. And what I'm going to do is append a paragraph for each. Now, this is done, you can think of it as in parallel, because we're passing the whole data. So it means for each data, I want to create a paragraph. Because for each one that enters, I want to create a paragraph for it if it's not there. If it's not there, meaning it does enter. And once, okay, so I'll step through. Okay, so as soon as we get to the enter, then we know that we have 3 data points and we have no paragraph, so we need to enter 3 nodes in the DOM that are symbolized by the 3 boxes there. Idea, I should put them in different separate boxes. I put them in the same, but I think you get the point. And at this point here, all this is always still the selection. So we had a selection that was initially empty. Then we had a selection that has 3 elements that we don't know what they are. But as soon as we say we want to append a paragraph on each one of those that are entering, then we actually realize the 3 paragraphs. And the bigger paragraph at this point, they're just blank. Right? So to set the text, we use again the selection and call the text function that is going to iterate through each one of the data points in the data set and set some text based on the data. So data driven. Okay. So, and here you see it with the dot text. Okay. Now here, the dot text, you can see the signature takes a function that takes this function is expected to take at least one argument that is the datum. So the data points are going to get passed one by one. And for each one of the paragraphs that are entered. Yeah. And so for each one of those, then this function, you have a chance to say what you want to return that is going to be set to the text. Here we're just returning the number. So the paragraphs are going to have as text the number itself. 0, 1, 2. Okay? So if you want to put hello word 0, then you just concatenate the strings and you return hello word as a string plus D. All right. So because oftentimes you want to also have the information about the index, you see that most of these functions in D3, they can take 2 arguments. The first one being the datum, and the second one is the index in the array. It's always relating to the data. Right? And so here what I'm printing is D equal the value from the data array and the index equal I, the argument, and this is the printout. Okay. And this signature is used throughout. So here I can use it with style to set the color. And here if I'm iterating through the data input. Yeah. So this is just the ternary operator that says that the reminder of the division by 2 is on null, then I'm going to set it to red, otherwise I'm going to set it to blue. Okay. Yeah, so this I told you, and I'm repeating it. The data set needs to be an array. And these are examples of valid arrays, right? So you see that you always have an array. It can be an array of objects. It can be an array of arrays. So obviously, if you have hierarchical data, then you have an array of arrays, and you need to handle it in there. Okay, so we're going to see some of the spatial cases because it allows you to do some specific visualization. So these are some tricky examples also for the quizzes. So you can see, but basically we've seen all the text, and I think I gave you the solution, so you can play around with it. Obviously, you can implement them and make them run if you want to see the output. This one is a little bit more complicated, but this is kind of the real world scenario. Normally, you don't deal with HTML with D3, but you fairly quickly get to this level of that much code to write. So that's why it's important usually to start from a good example, as opposed to start writing this line by line. Because in this thing, you're going to see that if you mix up, you put the enter before the data, it's not going to give anything good. And you won't see anything, it won't crash, it won't tell you anything bad about it, but your page is going to be empty. Okay, so this one, if you have questions, look at it, and we can answer it next time. So you see that D3 really is just DOM manipulation, the library to manipulate the DOM, and you use all the CSS and SVG HTML for creating the graphics. So now I'm going to give you a little bit of an introduction to Vega and Vega Lite, because they're quite popular. So this is something that you've probably seen already in notebooks, if you're familiar with Altair. So, or Altair, I never know how to say it correctly. But what Altair is doing is just a front-end library in Python to this thing. And the Vega comes with our ecosystem of tools that I'll try to give you a little bit of background on. So the short story is that it's basically the idea here is, can I specify a graphic by writing a JSON object? And it turns out that you can do that. So it's a little bit difficult for the human. But because all these tools are using JavaScript, it's obviously simple to handle for the browser. And you see that there are different levels of complexity depending on which specification you use. Some of it is human accessible. So how does it work? Well, somehow you need to write this specification for for the graphic. You can do it in either Vega or Vega Lite. If you're Vega, you're really good at it because you'll see it very verbose. The Vega Lite is more human friendly. And once you have done that, then there is a JavaScript library that is called Vega Embed that you can use in the browser to render, which means that you can put those in web pages, or you can use other pieces such as there is an online editor for the library that allows you to go in further. Customize this and export them to plain SVG or PNG, etc. So all these are part of the ecosystem. Now the Python interface, what they do is that they do the same, but when they go higher, they start here, they generate this Vega, and then they use this in the notebook to render. Okay, and this is what it looks like. I think this is just a picture, if I remember well, but in the website you have the interactive version of it. Yeah, I didn't bother to put it in there. So Vega Lite, so you see a little bit what it looks like in here. It's similar in syntax a little bit to some of the grammars that we're going to see, for instance, with ggplot2. And here you basically have the language specification here, the version of Vega that you're using. This is just for you to remember what it is. And then you have a field here with the data that again is an array. Because most likely they're using Diffie in the background. It just makes sense. Here it's an array of objects. And here we specify how we want to generate, which marks, which visual symbols we want to use to generate the graphic. And we want to use bars. So we're going to get a bar chart. And the encoding is what is called the static encoding. So this is basically what tells the grammar where the variable should go in on the axis. So here the A variable here is going to be mapped to the x-axis and the B to the y-axis, and you can specify the type of the axis. Because different axes obviously are going to be drawn in different ways, right? If it's a categorical or if it's a time axis, you will draw them in different ways. This is the fine print for exactly the same thing in Vega, because here there are a lot of the defaults that are not appearing, and the Vega is kind of the whole package where you get everything, including the defaults set up for you. This one is usually, if you need to tinker with it, you go in the editor and you can go and change it. And we're going to see how you do this in the lab. Yeah, and I'm just in time. All right, thank you.